Okay, how to find parallel and perpendicular slopes. So here we have a linear equation, and the slope in this equation is right here, okay, next to the x. So parallel lines have same slope, and perpendicular lines, you have to make two changes. They have to be the opposite sign, and it has to be the reciprocal fraction. So in this case, the line that's parallel to this will have the same slope. The slope will be -1/3. The perpendicular slope, well, we're going to change the sign, so it's going to be +1/3, and we're going to flip it, so it's 3/1. So it goes from -1/3 to +1/3, and flip it, 3/1, which reduces to just 3. This one over here, the current slope is 3, so the line that's parallel to it has a slope of 3. The slope that's perpendicular, well, let's put this in fraction form. Let's change the sign, and then let's flip it. Let's keep the negative on the top, though, when we do that. So this is the slope of the perpendicular line. For this one, the current slope is -2/5, so the parallel slope is -2/5. The perpendicular slope goes from -2/5 to +2/5, and flip it, +5/2. That's the perpendicular slope. Now sometimes they don't start with it saying y equals mx plus b in that form. Sometimes they start with a problem that looks like this, and you've got to get the y alone before you can see what any of the slopes are to do it. So you're going to subtract 2x from both sides, and that's going to give us the -2x plus 16, and then divide everything by -4. So it's going to be y equals, when you divide by -4, this will be a +2/4, because negative divided by negative is positive, and 2/4 is the same as 1/2. So that would be a +1/2. Whoops, and then this becomes -4. 16 divided by -4 is -4. All right, so the line that's parallel to this has the same slope, +1/2. The line that's perpendicular to this, we're going to give it a different sign. It's going to be -1/2, and then we're going to flip it so that that reduces to -2.